Good morning, students. I'm Kunal Vananji. Welcome to the first lecture of this semester. In this semester, we are having two papers for the physics. That is, first one is classical and quantum mechanics, and second paper is electrodynamics. So, for this semester, I'm taking this paper that is electrodynamics. So, today we are only taking the introduction of this paper. So name of the paper is the Electrodynamics, for which 45 periods are given and the 50 marks is given, in which according to the name of this paper, that is Electrodynamics, means in this paper we are going to study about the dynamics of the electric fields, means what are the changes, what are the variations in the electric field or different fields that will be discussed in this paper, that is called as electrodynamics. So in this we are having four chapters. First one electrostatics, second time varying field, third is electromagnetic waves, and last, that is fourth one, interaction of electromagnetic waves with matter. So initially taking first chapter, that is the electrostatics. So according to the name, that is the electrostatics, means in this chapter we are going to study about the static charges, means those charges which are stationary, which are not moving, so they are producing some electric field. So that electric field is studied, that is called as electrostatics. So in this electrostatics chapter we are taking first one introductions, in which we are going to study about the electric field lines, electric flux and Gauss law, in which again the divergence of electric field, curl of electric field, that is given, and according to that we are taking different applications of these electric fields, that is curl and divergence. So what are the applications? First one is the electric field due to uniform charged sphere, means if the charge is uniform, if the charge is circular or spherical charge, then which type of field it is producing. So that will be one of the application of this Gauss law. So that will be studied by using this Gauss law, that is nothing but electric field due to uniform charged sphere. Second one, if the charges are in the cylindrical form, so the cylindrically formed charges, they are producing the electric field. So that electric field is again studied by using this Gauss's law. So Gauss law is very much important in case of electrostatics, to study various types of electric fields produced by the various types of charges, in which again the important part, that is Gaussian pillbox and Poisson's equation. So these are the two equations which are used for the various types of or various shapes of the electric fields which is produced by different types of charges. The next one, Laplace's equation and uniqueness theorem, that is first and second theorem. So these two equations, or this equation and theorem, that is again useful to study about the electric field. So overall this chapter is depends upon the electric field produced by various types of charges. So this is the first chapter, for which the 12 periods are given. Then second chapter called as time varying field. So in this chapter we are going to study about the fields which are depends upon the time, means those fields which are changing with the time, that is called as the time varying field. So this variations in the field according to the time, that is given in this chapter. So for that we have to study first one, that is Faraday's law of electromagnetic induction. Already we know about the electromagnetic induction. So that is induction of electric and magnetic field simultaneously, and that is given by using the simple law of Faraday, that is called as Faraday's laws of electromagnetic induction, which is again given by another law, that is Lenz's law, and in which we are going to study about the two types of inductions. First one is self induction and second one is mutual induction. We already studied these two types of induction in the 12th standard also, but that was only the introduction. But here we are taking some brief idea about the self and mutual induction. Then second one, equation of continuity. Then Maxwell's displacement current, Maxwell's equation. So these are the different equations which are giving us the information about the time varying field. So this chapter is given 10 marks. Then that is the 10 lectures are given for this chapter. Then third chapter, that is the electromagnetic waves. So we already know that the light is nothing but the electromagnetic wave. That is, light is having electric field and a magnetic field, so it is combined, it is called as electromagnetic waves. So in this chapter we are going to study about all about the electromagnetic waves, means in its origin, then properties, different types of phenomena, then different types of theorems related with this electromagnetic wave that will be given in this chapter. So in which we are going to discuss, that is, origin of electromagnetic waves, then characteristics of electromagnetic waves, then electromagnetic wave equation in a conducting medium. We know that when light is passing in a vacuum as well as in a different media, so there is a change, there is a variation in the electric and magnetic fields. So that variations are discussed in different media. So here for this chapter it is given electromagnetic wave equation in case of only conducting medium, means when the light is passing from the conducting medium, then what happens with the electromagnetic waves. Then second one, transverse nature of electromagnetic wave. We already know that light is the transverse type of wave, so we have to prove that it is the transverse wave. So this is the transverse nature of electromagnetic wave, it is given in this chapter. Then plane polarized electromagnetic waves. Again, polarization of light is also known to us. So here it is given the plane polarized electromagnetic wave, means how that electromagnetic waves can be polarized in a single plane, called as plane polarized electromagnetic waves. Then Poynting vector, Poynting theorem, these are again related to the polarization of light. And finally polarization of electromagnetic waves. So there are different types of polarization, that is plane polarization, circular, elliptical. So such type of polarizations are again will be discussed in this chapter. So overall this chapter is related with the electromagnetic waves. So this chapter is having the more importance, which is given the 15 lectures. Then finally the last chapter, known as interaction of electromagnetic waves with the matter. So this is nothing but the spectroscopy. So simply spectroscopy means when the light is passing through different materials or different medium, so how that light will be interacting, so how that electromagnetic wave will interact with that matter is called as the spectroscopy. So this chapter is the brief introduction of that electromagnetic wave interaction with the matter, in which the boundary condition of electromagnetic field vectors, means when the light is passing from one medium to the another medium, there must be a boundary between these two media. So what happens with that electromagnetic wave at that boundary, that is called as the boundary condition. And so every vector of this electromagnetic wave field or the electromagnetic wave, that is given by different vectors. So this vector B and EH related with the magnetic field, and vector E and D are related with the electric field. So these are the vectors which will represent the variation of electromagnetic waves at the boundary of the two media, that is at the interface between the two media. The next point, that is the reflection refraction at the boundary of two non-conducting media, means again we know that some surfaces are refractive surfaces, some surfaces are reflective surface. So when light is passing through such a material or medium, so there may be a reflection or refraction. So what is the condition of this electromagnetic waves or the electromagnetic field during reflection and refraction? at the boundary of two non-conducting media that will be given in this chapter. So this chapter is again very interesting, which is given the 8 lectures. So overall these are the 4 chapters for this paper, that is total 45 lectures are given to us for the completion of this paper. So for this paper we are having different reference books. So that is known as Introduction of Electrodynamics by David J. Griffith, then Mechanics of Electrodynamics by Brijlal and Subramaniam and Jivan Seshan, then Classical Electrodynamics by S.P. Puri, then Electrodynamics by B.B. Loud, then Electrodynamics by Gupta Kumar Singh, and last one is Electromagnetic Waves and Fields by R.N. Singh. So these are the reference books for us to study or to refer all the points related with the syllabus. So this is about this paper, that is the electrodynamics. So during this total semester we are going to study about this electrodynamics. Thank you.